Hello, PascoMath grade 7 teachers. Today we're going to continue our learning on 7.NS.1.2, focusing on part B of the standard. So let's get started. 7.NS.1.2, apply and extend previous understandings of multiplication and division of fractions to multiply and divide rational numbers. Part B states, understand that integers can be divided, provided that the divisor is not 0, and every quotient of integers with non-zero divisor is a rational number. If p and q are integers, then negative quantity of p divided by q is equal to negative p divided by q, or p divided by negative q. Interpret quotients of rational numbers by describing real-world contexts. When unpacking the standard, we can look at division of rational numbers, can be thought of as inverse of multiplying, relying on the previous understandings of that relationship between multiplication and division. The equation negative quantity p divided by q equals negative p divided by q, which is equal to p divided by negative q, is for the teacher. And so that's not really what we want to, with the abstract piece, present the students. We also want to use p divided by negative q and p over negative q notation with students. Make sure that they have experience with both. So now let's focus a little bit on what the teacher should be doing in the classroom. The first thing is just relate the meaning of division with signed numbers to the meaning of division with whole numbers, using that inverse relationship of multiplication and division. And so we can just start as simple as 7 times 3 equals 21, and we know that 21 divided by 3 gives us 7. So we have that inverse relationship going on. And so if we look at 7 times negative 3 equals negative 21. So we're taking with whole numbers and extending to integers. We know that negative 21 divided by negative 3 gives us positive 7. So we just want to make that connection for students. We also want to expose students to many examples of division with integers, so they can just discover and establish the formal rules. And so again, that comes from the students. Use multiplication and division as inverse operations. So we're paying this forward and to our EE standards when we start to solve equations, talking about inverse operations, multiplication and division. I'd also encourage students to divide by 0 and have that class discussion of why it's not possible. And so we can, just start with context and say, well, I know that, let's just go 6 divided by 2 equals 3. And 3 times 2 equals 6. So we're talking about that inverse relationship. And we can say, something else like 8 divided by 2 equals 4. And we know 2 times 4 gives us 8. And then, again, if we're looking at repeated reasoning and patterning here, if we have anything, so let's just go 6 divided by 0, go back to 6, equals, well, some students might say 0. And so then if we say, then using the same reasoning, everything that we've done so far, then you'd be telling us that 0 times 0 equals 6. And we know that's not true. 0 times 0 does not equal 6. And so the pattern breaks down there. And so we want students to get to, maybe you can even reason a little more abstractly and just say that, well, if x times 0 equals, let's say, 5, then 5 divided by 0 equals x, and have them come up with, like, what number would that work for? And so if you want to torture them, you can allow them to, explore for a long time, or hopefully some students will realize, like, it is not possible. That is not mathematically possible. Again, be sure to use both p divided by negative q and p over negative q notation in the classroom with students with different examples. Another thing you can do is just challenge students and say, if negative 6 is the quotient, then what was the equation? And so if we just pose something like, all right, we have a quotient and the answer is negative 6. Like, what could be the equation? What are some possibilities? And have them explore what are some ways to get negative 6. Also provide real-world contexts where the quotients of rational numbers can be interpreted. Again, an example would be, let's say Sunday, So let's go Sunday. It was, let's just go 0 degrees Fahrenheit. And then 7 days later, let's say it was, that temp was, let's go negative 21 degrees Fahrenheit. So we're somewhere cold. We can just ask, what could negative 3 represent? So again, from this context, just Sunday, 0 degrees Fahrenheit. 7 days later, the temp was negative 21 degrees Fahrenheit. Like, what could negative 3 represent? And have students make sense of what it represents, how it was calculated, what it means in the context of the problem. We also want to provide opportunities for students to create real-world problems using division on themselves, not just ones that you provide them, and use writing as a formal assessment to learn. And so trying to get that student understanding of multiplication, division of numbers, rational numbers, and then provide ongoing practice and context so students can develop that fluency that we desire that they have with multiplication, division of rational numbers. So let's look at what we want the students to be doing for NS.1.2 Part B. And so the first thing is we want them to reason, determine that division by 0 is not defined. The teacher should set the conditions for the students to explore, and the students need to, through some patterning, figure out why division of 0 is not defined. We want the students to discover division as an inverse of multiplication, holds true for integers, and generalize the rules. So that should come from the students, not the teacher. Generalize the rules for division with signed numbers from multiple examples. The students should be comfortable using p divided by negative q and p over negative q interchangeably to represent division. They should be able to interpret a rational quotient in real-world context, clarify their understanding of the relationship between multiplication and division through writing, and develop fluency, but I can't stress enough, through context. So for some misconceptions, some students may not understand why the division of 0 is undefined. I tried to address that earlier in the teacher portion. So again, to address this misconception, I would encourage using some patterning to demonstrate the relationship between multiplication and division, and have students discover that the division by 0 breaks that relationship between multiplication and division. Therefore, it's not defined. That's it for 7NS.1.2 Part B. If you have any questions, feel free to contact me or your regional specialist. And thank you for making PascoMath more awesome.